Hi, my name is Erich Heuschele, and I'm in charge of Vehicle Dynamics at SRT, which is Chrysler's performance car division, where we make the Viper, the Charger, Challenger, Hellcat, and all the SRT products. The Viper ACR is an interesting piece, and it's a new car for us. It was great in that we were tasked with making the most racy street car on the market. So we really have a race car that has a license plate and you can drive it on the road, but it's actually intended to be a car that's driven on the track and to be the most capable car, hopefully in the world at the racetrack from a lap time standpoint. It has race car levels of aerodynamics. We can't quite drive the car upside down yet, but you've got about 1,400 pounds of downforce at 150 miles per hour. It's got racing tires. It's got Bilstein racing shocks from the factory. And of course the Viper with its V10 engine is capable enough. We didn't do anything to that, but all that downforce and all that grip just glues it to the track, and it's hopefully the fastest production car in the world around many racetracks. The Viper is America's exotic, but the thing about the Viper that makes it different is it's really affordable. It's an attainable car. It's not a $350,000, $400,000 car. It's a $100,000 car, and it has a big American aluminum V10 engine. It's rear-wheel drive. They're all manual transmission. We don't have a flappy paddle shifter, and it's really a driver's car, but somewhat of a throwback driver's car, but it's still as capable as anything in the world. The Viper's been around for over 20 years now, and we've always had an aluminum V10. It's grown in displacement from 8 liters, which is a little 488 cubic inches. It's now 8.4 liters. It's over a 500 cubic inch engine. Its horsepower has gone from 400 back when normal cars had 200 horsepower. Normal supercars had 200 or 300 horsepower. We were 400. We're now up to 645 horsepower, and it's actually the highest torque naturally aspirated engine in a car in the world. Hey, the rain's starting to let up. I think we can go for a ride. We're really lucky at SRT as engineers to be tasked with, okay, I want you to take a Viper and I want you to make it as fast as possible around a racetrack. So, you know, what we've learned from racing Vipers all these years is that, of course, aerodynamics is king, right? And we've got really otherworldly levels of aerodynamics on this car, you know, 1,400 pounds of downforce at 150 miles an hour, and it's significantly more than that when you get up to the car's top speed, which is almost 180 miles an hour. And that just crushes the car into the ground and crushes the tires into the ground without having the tires carry any more load to turn a heavy car. That's why road hugging weight doesn't exist, right? Because, okay, the tires are getting pressed harder into the ground, but they also have to turn more mass. So aerodynamics gives you that load that the tires can generate without having to move a heavier car. And then, you know, we have these tires that were specifically developed for this car from Kumho, which are hopefully, I think, have set the bar, or a new standard for racing tires that are still DOT street legal that we can sell to the public. And I think we even showed today, you can drive them in the rain. And I mean, you can't go through deep puddles at high speeds, but the grip level's still just amazing with the tires. We have racing shocks from Bilstein. We work with Bilstein on all of our SRT products, and we have double adjustable racing shocks from the factory. You can set compression and rebound. You can set ride height. You corner weight the car just like a race car. And then these amazing carbon ceramic brakes that are just don't fade. You can run them on the track just like endurance racing brakes, and they last multiple times longer than stock brakes normally would in a racing environment, and they're also significantly lighter for rotating inertia, and they just don't go away. They don't let you down. So what we really have here is the raciest Viper we've ever made, including some of the Vipers we've made which were pure race cars, which didn't have a VIN, and you couldn't drive them on the street. They weren't legal to drive on the street. They were just race cars. But here's a car that anybody can walk up and buy and take and, you know, drive it on the road and actually drive it at the track. And, you know, we have a lot of Viper customers who drive and who take their cars to the racetrack. If you think of the number of Vipers there are, which, you know, we don't make nearly as many Vipers as, you know, we don't even make a tenth the number of Vipers as Corvettes are made and Porsche 911s and things like that. A significant percentage of our customers do take their cars to the racetrack. And this is the ultimate racetrack Viper. You can take it to track days. You can, you know, say you get a Mustang or a Corvette or something like that, a car that is fairly capable, but still a normal street car with a lot of street car compromises. That's a car you can master in a few track days once you get to a certain skill level. And the great thing about a Viper like this, which really drives like a true professional race car, is that you'll spend years learning how to drive this car that's limited all the way around its track at different tracks. And that's just a lot of fun. You'll never get bored with this car. It's tunable to change the handling variance aerodynamically or mechanically with the suspension. And you'll spend years getting the most out of this car, and you'll come out of it a significantly better driver. You'll come out of it at the level, hopefully, if you can control this car and run get your skill level up and run the lap times, you'll be like a lot of professional race car drivers, and that's a pretty neat thing to do in a $120,000 car instead of Ferraris and Lamborghinis, which are $300,000, $400,000, $500,000 cars that might be too dear to risk. So it's kind of cool. And we spent a lot of time at racetracks. I mean, really, I've got one of the best jobs in the world, or the best job in the world as far as I'm concerned.
So where did the spark start?
Well, the spark, of course, started with my family, my dad and uncles and my grandpa. We've always been kind of a car nut family. And my grandpa owned gas stations, started cut rate gas around the time of the Depression. But when I was a kid, I remember going to a local go-kart racing track in northern Michigan. Nothing special, not like the great indoor racing car tracks I have now, just a normal outdoor go-kart track. And I started driving that go-kart. I think I was probably 9 or 10 years old. And something clicked with that. I could feel those tires. I felt like I was plugged into that go-kart. I wasn't sitting on top of that go-kart and moving the steering wheel and sitting in the seat. I was plugged into that thing, and it was a part of my body. And the car was communicating with me. I could feel what those tires were doing. I could feel their grip level and their capability. And I just remember, attaining that level of focus to feel the car communicate with me. And that was, a bit of an epitome for me. And I said, wow, this is something I really want to do. And I was always, a math and science kid. And when I went to, I started out in physics, actually, because I liked physics. But when I really thought about it in college, about what I wanted to do, I wanted to work on cars. I love cars. I've always loved cars. And so I changed direction from pure theoretical origins of the universe type of physics, which I still am greatly interested in and love, to wanted to work in the car industry. I switched universities when I went from physics to mechanical engineering. Western Michigan University at that time had a specific accredited mechanical engineering degree that was automotive based, and so I specialized early on in my bachelor's degree. But man, I just loved that, because instead of thermodynamics 2, we had internal combustion engines class. We have vehicle dynamics classes, and I remember going to those classes that were an hour and 2 hours long, and it feeling like it was 20 or 30 minutes, because I just loved the subject matter. And that's the great thing about college. You can learn about things that you're really, really interested in once you get through the basic classes. And I remember not taking a lot of notes because I remembered it all. And I got out of college and started working at a supplier, and eventually got in at Chrysler as a test engineer, testing things in the suspension lab, fuel tanks, exhaust systems, shock absorbers, tire testing lab. And over the course of a number of years, there was then, in doing well and working hard and having a lot of pride in my work and making sure everything was done correctly and mistakes weren't made. There were no problems with the data I was generating. That led to a job in suspension engineering back on the second generation Neon, first and second generation Neon. And that led into vehicle dynamics and eventually SRT, where our performance car group is. And it took 13 years, but I got my dream job 10 years ago at Chrysler.
When you were a kid or when you were in school, did you ever dream you'd be on a project like this?
Honestly, when I was in school, I couldn't even fathom that a job like this existed. I mean, I didn't really think about, okay, who decides how the tires are? I mean, I was learning about suspensions, and I know somebody said it, but I didn't know if you just did a bunch of math calculations, or, you know, I guess maybe you drove around the car a little bit. I learned about that later when I started racing cars, that there are guys at the car companies who specify all this stuff, but not really the path of how to do it. And what I found is that vehicle dynamics is a specialty where we actually specify, okay, what is the valving, hydraulic valving and the shock absorber, so that the tire stays connected to the road, so that the ride is acceptable. How stiff are the springs that we're running in the car, and why? Developing tires, when we do tires for cars, especially cars like SRTs, we specify, you know, you start with doing compound selections, how you want it to perform in the wet, the snow, the dry, and then into the tire construction, the response of the tire and all these fine details, and ultimately still meeting wear targets and all the other things that customers expect. But what you really do in vehicle dynamics is, with the exception of the powertrain and how the engine drives the car and how the engine responds to your right foot, the rest of the way the car feels is actually in vehicle dynamics realm. You know, I turn the steering wheel and the car responds back with some force feedback, and especially if you get some racing experience, you really get dialed into cars. I mean, I can feel those tire contact patches. I know that tire's telling me where it is and its capabilities, whether it's happy or not. And if it's not happy, I change something. Is it working better or not? I can feel the back tires through the seat. And it's one of those things in industry that's still somewhat of an art form. We're still not at the point where a tire can be accurately modeled as to how it behaves in all situations for ride and handling, where the vehicle modeling is still not there, where every possible kind of bump and turn is evaluated. Still, what we're doing in vehicle dynamics is we're still getting in cars and driving them and using subjective feedback and how that car feels to get the kind of response and feel we want out of the car. You know, some cars are more isolated from the environment. Some cars, like Vipers, are not very isolated at all, and that's because when you're driving on the track and you want to get the kind of feedback, you want to have a high amount of gain in the steering. You know, it's really sharp and precise, but I want that feedback from the car telling me how it's doing, how it's working, so that I can drive it on its limit as fast as it can possibly go. It has to communicate with me. If it doesn't communicate with you, which is like driving a video game, you can't feel the limit of a car on a video game if there's no feedback telling you how that car is working. And that's the big difference that video games haven't gotten to yet, but I'm sure they'll get there someday in the future. It's called a driving simulator.